Ay, tuloy tayo sa problem number 47. Find the width of the channel at the back of a suppressed weir using the following data. Ay, so H is equal to, or the head equal to 28.5 centimeters. Yung D naman is 2.845 meters. Yung discharge is 0.84 cubic meter per second. So consider the velocity of approach and use Francis formula. So dito sa Weirs, unahin natin yung mga rectangular. Pagdating sa rectangular weir, meron tayong dalawang formula na ginagamit dito. Kapag given yung coefficient of discharge at ordinary rectangular weir lang siya, the flow rate actual is yun yung 2.95. Coefficient of discharge ay the length of the crest, h raised to 3/2. That will be the formula for the flow rate actual. Pero kapag hindi naman given yung coefficient of discharge, at sinabi naman niya na Francis formula, ito rin yung medyo sikat na formula pagdating sa weir. Pagdating sa Francis formula, the flow rate actual is equal to, yun yung 1.84 LH raised to 3/2. So, based dito sa problem na to, sa number 47, ito yung parang appearance ng problem natin, yung illustration. Ito yung side view. Okay? Ito yung side view na nung weir. Ito yung nilagay natin na parang harang para mabawasan yung flow at para mag-appear lang siya na parang spillway. So, ito naman yung kanyang front view. So, hinahanap natin dito yung length. So, yung given na head, yun yung height ng liquid above the crest. At ito yung terms dito sa parang jump point ng tubig dito sa weir. The term is crest. So, yun yung height ng tubig. We have 28.5 centimeters. Ginawa ko lang siyang meter, 0.285 meter. Tapos yung D, yun yung nilagay na harang, that is 2.845 meters. So, sabi naman niya, gamitin daw yung Francis formula. Pwede nating i-neglect yung velocity of approach dahil negligible yun, medyo maliit yung kanyang value. Ito yung by Francis formula. We have the flow rate actual is equal to 1.84, the length of the crest times h raised to 3/2. Yung given na discharge is 0.84 equal to 1.84 L. Yung given na head is 0.285 meter raised to 3/2. So, kunin natin yung length ng crest na required. Is 0.84 divided by 1.84 multiplied by 0.285 raised to 3/2. That is 3 meters. So, sabihin na lang natin ay 3 meters. So, maliit lang yung difference kapag kinonsider natin yung velocity of approach. Ang lalabas lang dun is 2.9999. So, this will be our solution for this rectangular weir. So, I think siguro magpo-post ulit ako ng link para dun sa derivation ng kanilang mga formula. So, we proceed to problem number 48. A rectangular weir 1 meter high and one end contracted is installed in a rectangular channel 2.5 meters wide. Determine the rate of discharge for a head of 0.8 meter. So, kailangan nating i-consider yung statement na to, the one end contracted. So, for example, ito yung open channel. So, parang maglalagay lang tayo dito ng harang sa ilalim. Maglalagay lang tayo dito ng harang sa ilalim na 1 meter high. That is considered as a weir. Okay? Pero yung head daw is 0.8 meter. Sinabi niya sa problem na one end contracted. Kapag one end contracted, hindi natin gagamitin yung L. Ang gagamitin natin dito is the L prime. Okay, for one end contracted, anong equivalent ng L prime? That is equal to yung length ng crest or the width of the channel, that is L, minus 1n, 0.1. 10% ng total head. So, ibabawas natin yun. So, kapag 2n contracted naman, kapag 2n contracted naman, ang gagamitin natin dito na L prime will be equal to, that is the L, okay, from the word na 2, that is 0.2. 20% ng total head. So, yun yung parang clue natin. Kapag 1n, 0.1. Kapag 2n, 0.2. So, wala ring given sa problem na coefficient of discharge. Okay, kung titingnan natin maigi yung problem, hindi siya nagbigay ng value ng C. So, kung wala yung value ng C, okay, ang gagamitin natin dito is the Francis formula. Ito yung the flow rate actual is equal to 1.84 LH raised to 3/2 since wala tayong given na coefficient of discharge. Tapos, kapag may contracted or contraction, so ang gagamitin natin dito is the L prime. So, instead na L lang, L prime. Okay, Francis formula is 1.84. This time, L prime times the head raised to 3/2. So, kunin natin yung the rate of discharge. We have the flow rate actual is equal to 1.84. Or kunin muna natin yung value ng L prime. So, dito tayo sa 1n contracted. This is, okay, the L prime is equal to L, that is 2.5. Okay, 2.5 meters minus 0.1. Ano yung given na head? 0.8. So, this will be L prime equal to, this is 2.5 minus 0.1 ng 0.8. This is equal to 2.42 meters. So, this is 2.42 meters. Ito lang yung parang effective width na dinadaanan ng tubig. So, that will be equal to, yung equivalent ng, the flow rate actual is now equal to 1.84 multiplied by 2.42, then multiplied by the head, that is 0.8 raised to 3/2. So, this will be the discharge in terms of the cubic meter per second. So, this is 1.84 times 2.42 multiplied by 0.8 raised to 3/2. Is 3.186. So, sabihin natin, this is 3.186 cubic meters per second. For question number 48. Check natin. 3.186. So, closest value is 3.19. So, ito yung solution natin sa problem number 48. So, dito tayo sa problem number 49. A symmetrical trapezoidal weir with sides loop to horizontal for vertical has a wastewater flowing it. If the head is 0.75 meters and the crest length is 2 meters, with C, that is coefficient of discharge for rectangle 0.60 and C coefficient of discharge for the triangle 0.62, determine the discharge. So, take note na wala tayong specific formula sa pagkuha ng discharge from a trapezoidal weir. So, kung mapapansin nyo sa isang trapezoidal weir, combination ito ng dalawang shape. So, rectangular at saka triangular. Isa-separate natin. So, ano ba yung formula kapag triangle? Ay, kapag triangular weir yung usapan, we have the flow rate actual is equal to 2.36 coefficient of discharge. This is the tangent of theta over 2 multiplied by the head raised to 5/2. Ito yung parang kapag ordinary triangular weir. For the case naman, for example, na yung value ng theta is equal to 90 degrees. Okay, so pwede daw minsan i-compute yung flow rate actual equal to the 1.4 raised to times the h raised to 5 over 2. Just in case may encounter natin yung special case na yan. So 90 degrees, 1.4 h raised to 5 over 2. So paano natin kukunin yung total discharge? Kapag trapezoidal, the total discharge equal to yung discharge para dun sa rectangular portion plus yung discharge mula dun sa triangular portion. So kung given naman yung mga coefficients natin, parang direct sub lang din tayo dito. We have the flow rate actual is equal to, kapag rectangular, yun yung 2.95, coefficient of discharge, L, H, raised to 3 over 2. Plus, yung triangular portion, ito yung 2.36, coefficient of discharge, the tangent of theta over 2 multiplied by the head raised to 5 over 2. So by the way, kapag trapezoidal weir, meron din ulit tayong special case. Okay? Kapag i-consider natin yung angle dito, ito yung ating theta over 2. Okay, theta over 2, ganun din dito sa kabila. Okay, the theta over 2. So ano equivalent ng theta over 2? So based sa given na slope, it is 2 horizontal, 4 vertical. Okay, 2 horizontal, 4 vertical. So kung kukunin natin yung equivalent ng tangent of theta over 2, ito yung the tangent of theta over 2 is equal to opposite, yun yung 2, adjacent niya yung 4. Or basically, yung equivalent of the tangent of theta over 2 is, ano yung 2 over 4? That is, 1 half. Meron tayong special case dito pag trapezoidal weir. Yung tawagin is yung special case dito is yung Cipullietti. The Cipullietti weir. So, kailan siya nagiging Cipullietti weir? If yung equivalent ng tangent of theta is 1 over 4. Or kung titingnan natin yun sa slope, yung slope niya is, for example, ito yung sloping side niya, that is the same as 1 horizontal, 4 vertical. Okay? So, kapag Cipullietti weir, ang equivalent ng discharge is equal to 1.859 LH raised to 3 over 2. Ito naman yung special case natin. Kapag trapezoidal weir siya, tapos the tangent of theta is 1/4 or slope, 1 horizontal, 4 vertical. Pero kung titingnan natin ito, yung equivalent kasi ng tangent of theta is 1 half. So, ibig sabihin, hindi siya Cipullietti. Ordinary trapezoidal weir. Okay, so mag-substitute na tayo. Okay, so we have the flow rate actual. Yung flow rate actual is equal to, this is 2.95. Ano yung coefficient of discharge para dun sa rectangular portion? That is 0.60. That is 0.60. Ano yung L natin? That is 2 meters. Okay, yung given na head is 0.75 meter. Multiplied by 0.75, this is raised to 3 over 2. Plus, yung triangular part is 2.36. Coefficient of discharge sa triangular, that is 0.62. So, multiplied by 0.62, ano equivalent ng tangent of theta over 2? Okay, kinuha na natin yun kanina. The equivalent of tangent of theta over 2 is, 1 half. So, the tangent of theta over 2 is, okay, lagyan na lang natin na eksaktong 1 half para hindi na natin kunin yung angle. Okay, multiplied by 1 half, then the head is 0.75. This is raised to 5 over 2. So, kunin natin yung total discharge for this trapezoidal weir. Okay, so, rectangular, 2.95. Coefficient of discharge, 0.6. L is 2. Okay, the head is 0.75. Okay, raised to 3 over 2. Okay, then plus, dun sa triangular, 2.36. Coefficient of discharge is 0.62. Tapos, yung tangent of theta over 2 is 1 half. Then, okay, multiplied by the head, that is 0.75, okay, raised to 5 over 2. That is 2.656, 2.656 cubic meters per second. Tama ba? 2.656 cubic meters per second. So let us check if we have this value sa choices for problem number 49. Okay, 2.656, that will be letter B. Pinakamalapit na, 2.66. So ito yung solution natin for problem 49, trapezoidal weir. Okay, so problem number 50. A rectangular spillway controls a reservoir 4.6 hectares in area. The permanent crest is at elevation 75 meters. If the water can be drawn from elevation 76.5 to 75.5 meters in 42 minutes, determine the length of the spillway in meters. Tapos, okay, sinabi niya dito, specific siya, use Francis formula. Okay, so kapag may involved na naman na time, okay, yung case na ito ng weir will be the falling head, na kapareho nun sa orifice. So magko-consider tayo dito ng falling head na case. So pag falling head, balikan lang natin yung concept, paano kunin yung time or kung may involved na time. Okay, balikan nyo lang yung basic ng discharge. Ang discharge is simply negative differential volume, okay, divided by the differential time. So, we'll be having the differential time is equal to negative differential volume is yung area ng reservoir times the differential H, okay, divided by the flow rate actual. Hindi ito practical na i-derive for a reason. Ay, paano kung nag-iba yung shape ng weir? Paano kung ibang case siya? For example, ordinary rectangular, triangular, trapezoidal, and so on. Ang problema dito, ang daming formula ng QA. So, kailangan, alam lang natin yung basic concept. Dito tayo lagi magsisimula. Ano ba yung equivalent ng QA? Di ba pag rectangular, 2.95 C sub D L H raised to 3 over 2. Kapag Francis, 1.84 L H raised to 3 over 2. Kapag triangular, 2.36 C D, the tangent of theta over 2 times H raised to 5 over 2. So, ang daming possible appearance. Okay? Marami siyang possible na appearance ng formula kung i-derive natin. Kaya dapat alam lang natin kung saan tayo pwedeng simula. Okay? The QA is equal to negative differential volume over the differential time. So, for this case, okay, gawin natin, that is the differential time is equal to negative area differential head. This is divided by QA. Ano yung QA ni Francis? Yun yung 1.84 L H raised to 3 over 2. Tapos, integrate natin both sides from 0 to t yung kabila. Ito naman, from initial head to the final head. So, we'll be having the equivalent of time is now equal to negative area divided by, separate natin yung mga constants, 1.84 L. Kung itataas ko ito, magiging H raised to negative 3 over 2. Kung i-integrate natin, so plus 1 yung exponent divided by negative 3 over 2 plus 1 to be evaluated from initial head to the final head. Okay, then kung isi-simplify pa natin ito, we'll be having the time is now equal to negative 3 over 2 plus 1 is negative 1 half. Ang reciprocal nun is, ano ba yun? So, negative 3 over 2 plus 1 is, obviously, this is negative 1 half. Reciprocal niya is 2. So, times negative, so magpa-positive na yun. So, twice the area divided by 1.84 L. Ito rin naman, magiging negative yung kanyang exponent. So, ang maiiwan dyan is Okay, ito. So this is a negative 1/2. So we'll be having, that is, h, or the final head. Ito yung final head raised to negative 1/2 ay minus the initial head raised to negative 1/2. Okay, kung sisimplify pa natin ito, I will be having the time is now equal to twice the area divided by 1.84 L. This is multiplied by 1 over, para mag-positive yung exponent, the square root of the final head minus 1 over the square root of the initial head. Kaya minsan hindi nga sa practical i-derive for a reason. Paano kung iba yung shape? Okay. Maliban na lang kung gusto nyong i-derive isa-isa, then i-memorize ninyong lahat. Okay? So, yan yung gagamitin natin dito. That is yung time is equal to twice the area divided by the 1.84 L. This is multiplied by 1 over the square root of the final head ay minus 1 over the square root of the initial head. Okay, again ito yung resulting formula niya dahil ang ginamit natin ay yung Francis formula. Okay, so depende kung ano yung QA na gagamitin. So ano yung mga kailangan natin dito? Ano yung area na yon? That area is equal to 4.6 hectares, yung area ng reservoir. This is multiplied by 10,000 square meters is to 1 hectare. So yung area na to is 4.6 times 10,000, that is 46,000 square meters. Ano naman yung ating initial head? Okay, yung initial head, yun yung height ng liquid above the crest. Yung height ng tubig above the crest. So that is basically 76.5 ay minus 75, yun yung ating head number 1. So 76.5 minus 75 is 1.5 meters. Tapos, ito naman. Okay, ano yung 75.5 minus 75? Ito yung head number 2. So, head number 2 is simply 0.5 meter. 0.5 lang yun. 75.5 minus 75. Okay? So, mag-substitute na tayo. Yung time pala. Yung time is 42 minutes. So, head number 1 is 1.5 meters. Head number 2 is 0.5 meter. Yung time is 42 minutes, gawin ko siyang seconds. So, times 60. So, ano yung equivalent ng 42 times 60? 2,520. So, 2,520 seconds. Okay, hinahanap natin dyan yung L. Okay, so mag-substitute tayo. So, this is the time is equal to 2,520 seconds is equal to twice the area. Ang area is equal to 46,000 square meters or 4.6 hectares. This is divided by 1.84, unknown yung L. Okay, yun yung hinahanap natin. And then this is to be multiplied by 1 over the square root of the final head is final head natin is 0.5. Ay minus 1 over the square root of the initial head. Initial head naman ay 1.5 meters. Okay, so mag-shift solve na lang tayo dito. Okay, 2,520 is equal to, this is twice of 46,000. Okay, divided by 1.84. Alpha x na lang yung unknown. Okay, then this is multiplied by 1 over. This is the square root of 0.5 ay minus 1 over the square root of 1.5 meters. Okay, so shift solve. Lumabas na rin ito one time sa board exam. 11.859. So we'll be having the length of the crest is 11.8 59 meters. Okay, check natin if we have this value sa choices for question number 50. Okay, 11.859, that will be letter B tayo, 11.86. So this will be our solution for question number 50. Falling head ng isang rectangular weir using the Francis formula. Okay, so problem number 51 tayo. A B-notch weir is located or cut at one end of a tank having a horizontal square section 10 meters by 10 meters. If the initial head on the weir is 1.2 meters and it takes 375 seconds to discharge 100 cubic meters of water, what could have been the vertex angle of the weir? I use coefficient of discharge ay 0.60. Ito yung cross-sectional area ng tank natin, 10 meters by 10 meters. So obviously, the area will be 100 square meters. Okay, ito naman yung parang front view ng B-notch weir or basically triangular weir. Okay, sinabi niya sa problem, the volume discharged is 100 cubic meters after 375 seconds. Kaya kung may involved na time, again, falling head na naman yung case na to, katulad nung previous example, pero this time, triangular weir. Okay, so magbe-base pa rin tayo dun sa start, yung initial concept ng discharge ng orifice or weirs. Ito yung flow rate actual is equal to negative differential volume divided by the differential time. So we'll be having the equivalent of the differential time is equal to negative area of the tank, differential head, divided by, ano yung flow rate actual kapag triangular? Ito yung 2.36 coefficient of discharge, the tangent of theta over 2, multiplied by the head raised to 5 over 2. Yun. So, yun yung disadvantage kapag weir, maraming masyadong types of weirs. So, if you are to integrate both sides of the equation from 0 to t, ito naman from the initial head to the final head. So, this is the same as time. Ilabas natin yung mga constants. This is negative area divided by 2.36 coefficient of discharge, the tangent of theta over 2. Kung itataas natin yung h na to, that is the same as h raised to negative 5 over 2. Kung i-integrate natin, that is plus 1. The same lang sa denominator kung ano yung ginawa natin sa exponents. Negative 5 over 2 plus 1. Ano yung negative 5 over 2? That is, we have negative 5 over 2 plus 1. That is negative 3 over 2. Then, reciprocal nun. Okay. So, yung result nito is negative 3 over 2. Ganun na rin yung exponent. Negative 3 over 2. So, reciprocal of negative 3 over 2 is 2 over 3. Tapos, negative times negative, that will be positive. So, that is, we have that time is now equal to positive 2 over 3 of the area divided by 2.36 of coefficient of discharge the tangent of theta over 2 and then multiplied by this is upper limit 8 sub 2 raised to negative 3 over 2 minus lower limit 8 sub 1 raised to negative 3 over 2. So, ito yung parang formula na pagdating sa triangular weir, which is iba na naman compared dun sa previous example natin na rectangular. So, ano yung initial head natin? Okay, we have the initial head that is 1.2 meters. Based na rin sa problem. So, head number 1. Ano yung head number 2 after 375 seconds? So, obviously, nagbawas tayo ng liquid. Nagbawas tayo ng liquid. Sabi niya, nabawasan daw siya ng 100 cubic meters. Ito yung, dito natin kukunin yung final head. Let's say this is head number 2. So, let's say yung nabawas na height ng tubig is D. Paano nakuha yung D? Basically, ano ba yung equivalent ng volume? Ang volume is yung area ng tangke times the depth ng tubig na nawala. Okay, so that is equal to 100 cubic meters. 100 cubic meters, ano yung cross-sectional area ng tangke? 10 by 10 yon, so that is the same as 100. So, multiplied by the D, obviously, yung mawawala na depth ng tubig kapag nakapag-discharge ng 100 cubic meters ng tubig ay 1 meter. So, sabihin natin, kung nawala yung 100 cubic meters ng tubig, mawawala yung 1 meter. Ano na yung remaining height ng tubig na naiwan kung 1 meter yung mababawas? So, basically, ay yung h sub 2 na to, okay, yung equivalent ng h sub 2 is equal to the 1.2 minus 1. So, yung h sub 2 natin is equal to 0.2 meter. Ito yung mga kailangan natin para sa formula. The final head, 0.2, and yung initial head natin is 1.2 meters. So, mag-substitute na tayo. Okay, ano yung nakuha natin? Ano yung given na time? That is, we have 375 seconds is equal to, this is 2 over 3. Yung area ng tangke is 100 square meters. This is divided by, this is 2.36. Coefficient of discharge is 0.60. The tangent of theta over 2, this is multiplied by, ano yung final head? 0.2 raised to negative 3 over 2 minus, initial head is 1.2 raised to negative 3 over 2. Yan. Kunin natin yung value ng theta. Tingnan natin kung kaya ito ng ship solve. Is 375 is equal to, we have that as 2 over 3 ay ng 100. This is 2.36. Coefficient of discharge is 0.6. The tangent of alpha x divided by 2. And then to be multiplied by, that is 0.2 raised to negative 3 over 2 minus 1.2 raised to the negative 3 over 2. Okay, let's try ship solve. That's 105.21. Sige, we have 105.21 degrees. So, let us check if we have this value sa choices for question number 51. Okay, so closest value, that will be letter C, 105.2 degrees. So, ganito kapag falling head sa weir, ito lang yung concept natin talaga. Yung flow rate actual is equal to negative differential volume over differential time. Magbabago lang yung laman ng QA. Depende kung ano yung formula na gagamitin o yung shape ng weir. Okay, ito yung solusyon natin for problem 51. Okay, so we proceed to problem 52. So a jet of water flowing at the rate of 0.12 cubic meter per second hits a vertical building wall horizontally at close range with a force of 7,000 newtons. So determine the diameter of the jet in millimeters. Ito yung topic natin na dynamic force. Ito yung force exerted by a fluid or a liquid pag tama niya sa object. Ay manggagaling lang ito dun sa second law of motion by Newton. Okay, ito yung force is equal to the mass times the acceleration. So basically, ang density is equal to the mass divided by the volume. Kaya kung mag-compute tayo ng mass, equal yun sa density times the volume. Tapos yung acceleration naman is the change in velocity with respect to time. Ngayon, kung isa-substitute natin yung mga equivalent na yan, ay magkakaroon tayo ng equivalent ng force. Okay, ano yung equivalent ng mass? Yun yung raw volume. Ano yung equivalent ng acceleration? Ito yung change in velocity over time. Ngayon, kung isa-separate natin ito, ano yung equivalent ng volume? Okay, what is volume over time? For example, volume, that is cubic meter. Ano yung time? Let's say seconds. Di ba, ang cubic meter per seconds ay isang unit for discharge, yung Q. Kaya minsan, we have this formula, tapos pwede nating sabihin pala yung change in velocity is the V1 minus V2. So we have the force is equal to the density times the discharge multiplied by V1 minus V2. Kapag the same direction yung dalawa, yung V1 at saka V2, ang gagawin dito, plus or minus pala dapat ito. Kapag the same direction, it should be minus. Pero kapag opposite direction, for example, V1 pakanan, then V2 pakaliwa, ang gagamitin naman na operation ay plus. Okay? So, pwede natin gawin dito. Yung B1, i-assume ko na yun yung velocity ng tubig. That is the h sub 2u. Sabihin natin, velocity of water. Tapos yung B2 naman, the B sub 2, ito naman yung sa wall. Di ba, kung wall, hindi yan gumagalaw. So, basically, our B sub 2 dito will be 0. So, ang gumagalaw lang dito is yung tubig. Balikan natin yung derived formula. Ito yung the dynamic force is equal to density discharge multiplied by B1 minus B2. Ano daw yung force na nag-a-act dun sa wall exerted by the water? Ito yung given is the 7,000 newtons. Ang equivalent ng newtons ay kilogram meter per second squared. Equal to the density of water. Ano yung density ng tubig? Basically, this is 1,000 kg. 1,000 kilograms per cubic meter. Ano yung equivalent ng given na discharge? Yung discharge is 0.12 cubic meter per second. So this is 0.12 cubic meter per second. Multiplied by V1 minus V1, yun yung sa tubig ulit. V1 sa tubig, V sub 2 is 0 dahil yun yung velocity ng wall. So, V1 is equal to, V1 minus V sub 2, that is 0. Kung mag-unit analysis tayo dito, cancel na yung kg. This is cubic meter, cancel na rin. Second squared. May maiwan na seconds dito sa ilalim. So, basically, velocity yon, kaya meters per second. Compute natin. Ano yung magiging equivalent ng V1, the velocity of water. So that is 7,000 newtons divided by 1,000 multiplied by 0.12. That is 175.3. 175 over 3. 175 over 3 meters per second. That is the velocity of flow ng tubig. Ngayon, hinahanap lang natin dito yung diameter. So, kung naghahanap tayo ng diameter, di ba meron na tayong discharge. Given ito, 0.12 cubic meter per second. Basically, ang discharge ay area times velocity. This is 0.12 equal to area pi d squared divided by 4. Then yung na-compute natin dito na velocity, that is the 175 over 3. So, makukompute natin yung diameter. Una, yung value na to will be in meter. So, multiplied by 1,000 millimeters. So, we can have the diameter in mm. So, this 0.12 is equal to, this is shift pi, sabihin natin, alpha x squared divided by 4. Since diameter yan, the velocity is 175 over 3. Shift solve. That is 0.0511. Pero meter yan. So times 1,000. That is 51.178. Sabihin na lang natin. This is 51.178 millimeters. So, check natin if we have this value, 51.178 millimeters as the diameter of the jet. So obviously, pinakamalapit na dito will be, letter A, that is 51 millimeters. So, example natin for dynamic force. So, ito lang naman yung formula na gagamitin natin. Raw discharge ay B1 plus or minus B2. Ay, so, dito na tayo sa problem number 53. So, water issuing vertically from a nozzle having a diameter of 25 millimeters flows out under a head of 30 meters. If C, or the coefficient of discharge, is equal to the coefficient of velocity equal to 0.98, I determine at what constant height could the jet of water support a load of 200 newtons vertically from the nozzle tip. So, parang ito yung setup natin. Ito yung tubig. So, meron daw weight dito. The weight is equal to, or load is equal to 200 newtons. Gaano raw kalayo dapat, that is yung distance, y. Kung ito yung mga details ng tubig, yung coefficient of discharge, C sub D or C sub B, equal to 0.98 under a head of 30 meters. So, by mechanics, di ba para ma-support niya, para hindi gumalaw itong object natin, so, sabihin na lang natin na yung B sub 1, B sub 1 is yung sa tubig. Okay, H sub 2O. Tapos, yung B sub 2 natin ay sa object. Or yung load na 200 newton. Since iso-support niya, i-maintain niya yung height na y, so dapat hindi gagalaw tong object na to. So again, yung B sub 2 dito will be equal to 0. So ano dapat yung force? Okay, yung impact, yung pagtama ng liquid, ano daw dapat yung magnitude ng force dyan? So by mechanics, di ba, by equilibrium, if we are to do summation of forces vertical equal to 0, assuming upward forces to be positive, so basically, yung force na itatama ng tubig should be equal to the weight. So the force should be equal to the weight or simply equal to 200 newtons. Okay, kung babalikan natin, ano yung equivalent ng dynamic force? Ito yung force exerted by fluid pagtama niya sa object. Ito yung density, discharge, multiplied by B1 minus B2, yung sa previous example natin. Saan tayo kukuha ng discharge? Galing dito. So, paano ba kumuha ng discharge? Yung, kung i-recall natin, parang orifice yung mga details na given. Flow rate actual ng orifice is the coefficient of discharge. Area ng orifice, the theoretical velocity or equal to C sub D. Area of the orifice, the square root of 2g h. Since may given siya dito na head equal to 30 meters. So, i-recall lang natin ng konti yung formula natin sa orifice. Okay, so flow rate actual is now equal to coefficient of discharge is 0.98. Area ng orifice, 25 mm. 0.025 squared pi divided by 4. Then the square root of 2 times 9.81 under a head of 30 meters. So, punin natin yung discharge or the flow rate actual. 0.98. Okay, area ng orifice, 25 mm. Multiplied by the square root of 2 times 9.81 under a head of 30 meters. Okay, so sabihin na lang natin 0.117 cubic meter per second. Okay? So, ang gawin natin dito, kunin natin yung velocity ng tubig pagtama niya dun sa object. So, the force or the magnitude of the force is the same as 200 newtons to be in equilibrium. Density of water is 1,000. Discharge is 0.0117. Tama ba? 0.0117 cubic meter per second. Okay, then multiplied by B1, velocity ng tubig, pagtama niya sa object. Then minus B sub 2, yung object hindi ulit gumagalaw, kaya yung velocity nito should be 0. So, makukuha natin yung b sub 1, yung velocity ng tubig pagtama niya dun sa object. So, that is the same as 200 divided by 1,000 ay multiplied by 0.0117. That is, okay, 17.094. Let's say 17.094 meters per second. Okay? Ito yung velocity ng tubig pagtama niya sa object. So that is equal to 17.094 meters per second. Pero pwede rin natin siyang i-assume na the final velocity. Okay, final velocity. Ano ba yung initial velocity natin dito? Paglabas niya dito sa nozzle. Okay? Paano natin kukunin yung initial velocity? Ito yung parang actual velocity natin. Dun sa orifice ulit. Ang actual velocity will be our initial velocity equal to the square root of 2g h. Or para maging actual pala, kailangan natin ng coefficient of velocity, the square root of 2gh. So, recall lang natin ng konti yung formula natin sa orifice. So, we have the initial velocity is, okay, c sub b, pareho lang doon sa given kanina, 0.98. The square root of 2 times ay 9.81 ay under a head of 30 meters. So, initial velocity natin will be equal to ay 0.98 ay the square root of 2 times ay 9.81 ay times 30 meters na head. That is 23.776 ay 23.776 meters per second. Check natin. Okay. So, ngayon, ay kindly imagine lang yung sa P6 natin, ay parang P6 na to, wala na siyang kinalaman sa fluids or hydraulics. Ay parang nagbato ka ng object pataas. Ay from initial velocity, ang initial velocity niya paglabas niya sa nozzle is 23 ay 23.776 ay meters per second. So pagdating niya dito, nagkaroon na siya ng final velocity, yun yung b sub 1 natin kanina. Yung velocity ng tubig pagtama niya sa object. The 17.094 meters per second. Okay, ano yung distance na naabot niya? Okay, i-recall lang natin ulit. This is a formula sa P6. So hopefully, naalala niyo yung mga formula natin sa P6. Ito yung parang final velocity squared is equal to the initial velocity squared, okay, plus 2g. Instead of h, gagamit na lang ako ng y para hindi tayo ma-confuse. So, instead of h, y. Okay, formula ulit to sa P6. Again, kapag yung direction is upward, negative yung g natin. So, final velocity is 17. The value of final velocity is 17.094 squared is equal to initial velocity, 23.776 squared. Okay, plus, this is twice of negative 9.81, acceleration due to gravity. Okay, multiplied by the distance, y. Okay, compute natin. Okay, 17.094 squared is equal to 23.776 squared. Okay, plus, okay, 2 times, ay negative acceleration dahil pataas, 9.81, ay times, ay alpha x. Okay, so, shift solve. That's 13.919. Okay, we have the value of y is now equal to 13.919 meters. Okay, tama ba? 13.919. So, let us check if we have this value sa choices for question number 53. So, I don't know, pero ang pinakamalapit na dito siguro, try nyo i-compute using stored values. 13.85. So, yung pinakamalapit na sa 13.919. Okay, so ang sagot natin dito will be letter A tayo. Okay, so dito na tayo sa problem, 54 to 56. So water from a reservoir flows through a non-rigid pipe, 600 millimeters in diameter with a velocity of 2 meters per second, is completely stopped by a closure of a bulb situated 600 meters from the reservoir. The pipe has a thickness of 20 mm. Bulk modulus of water is 2.20 times 10 raised to 9 pascals or newtons per square meter. And modulus of elasticity of the pipe is 1.4 times 10 raised to 11 pascals. Ito yung water hammer pressure kung tawagin or water hammer. So for example, ito yung malaking reservoir natin. Tapos, for example, nagpo-flow yung tubig. Tapos bigla nating isasara yung bulb. Yung pagsara ng bulb na yon, magkukos yun ng sound. So obviously, yung sound is magta-travel paalis muna, then obviously mag-e-echo, babalik. Yan. So pabalik-balik yan. Okay, pabalik-balik yung sound. Kaya sa tinawag na water hammer dahil pabalik-balik. Parang kung nagmamartilyo tayo, paulit-ulit nating pinupukpok yung pako. Okay, so yung tawag natin sa velocity of sound na yun is the celerity. Okay, the pressure wave or the celerity. Meron tayong two cases. Ito yung una is yung kapag rigid pipe, yung value ng celerity or the velocity of the pressure wave is the square root of K divided by the density. So minsan yung K na yun class is beta. So the bulk modulus of water. Kapag non-rigid naman, ano yung equivalent ng celerity? So the equivalent of the celerity is the square root of, ito yung bulk modulus of water, divided by the density of water, multiplied by 1 plus the diameter of the pipe, the bulk modulus, divided by the modulus of elasticity times the thickness of the pipe. Ito yung two cases natin. So it's either rigid pipe or non-rigid pipe. Okay, so for question number 54, yun, compute the velocity of sound in water. That is the celerity. Sinabi niya class sa problem that this is a non-rigid pipe. So doon tayo sa non-rigid. Kapag ito na yung mga units natin, more likely direct sub na lang tayo. So we have number 54. We have the celerity is equal to the square root of the bulk modulus of water. This is divided by the density of water. Multiplied by 1 plus pipe diameter, bulk modulus, divided by modulus of elasticity of the pipe times the pipe thickness. So substitute. We have the celerity is equal to the square root of K natin. So minsan daw hindi ito given. Paki-memorize the bulk modulus of water. 2.20 times 10 raised to 9. This is to be divided by the bulk, the density of water, yun yung 1,000 kilograms per cubic meter. Multiplied by 1 plus, pipe diameter is 600 mm. Okay, bulk modulus, 2.20 times 10 raised to 9. Okay, to be divided by, the modulus of elasticity of the pipe is 1.4 times 10 raised to 11. Then, to be multiplied by the pipe thickness, that is 20 millimeters. Okay, so kunin natin, what is the velocity of the sound wave or the celerity? This is 2.2 times 10 raised to 9. Divided by density of water is 1,000 multiplied by, that is 1 plus, pipe diameter is 600. Bulk modulus is 2.2 times 10 raised to 9. Divided by 1.4 times 10 raised to 11. Modulus of elasticity ng pipe. Tapos yung 20 millimeters thickness ng pipe. So kung mag-unit analysis ka dyan, magka-cancel kasi lahat ng unit. So this is equal to 1,222.761. So 1,222.761 meters per second. Velocity ito, kaya meters per second. So 1,222.761. Check natin sa question number 54. So the closest value will be letter A, 1,222.8 meters per second. Sa number 55, Okay, determine the round trip time for the pressure wave to travel through the pipe. Yung round trip time, okay, parang ganito lang yung analysis natin. Ang round trip is, di ba, round trip, papunta at saka pabalik. So, papunta, yun yung length ng pipe. Pabalik, another length ng pipe. Okay? So, basically, ano ba yung equivalent ng velocity? Yung celerity is velocity. That is basically distance over time. Ano yung total distance? Papunta at saka pabalik. Ang papunta ay L, pabalik ay L. So, the total distance is 2L. Ano yung T natin? Yun yung, let's say, T na lang. Yung T na to will be the round trip time. Round trip time, velocity is distance over time. Ayun lang naman. So, kung nagko-compute tayo ng round trip time, that is basically twice the length of the pipe divided by the celerity. So, yun lang naman siya. So, we'll be having question number 55. This is twice yung length ng pipe is 600 meters divided by yung celerity na nakuha natin sa number 54, 122.761, 1,222.761. This will be the round trip time. This is twice of 600. Okay, to be divided by 1,222.761. That's 0.981 second. 0.981 second. Okay, let us check if we have this value sa question number 55. So we have that as letter A tayo. 0.98 second. Number 56, I calculate the water hammer pressure due to instantaneous closure. So, meron tayong different types of closure dito sa water hammer pressure. Okay, kapag yung, let's say, T sub C, sabihin natin ito yung time to close the bulb. Gaano natin kabilis isasara yung switch niya, kumbaga. If the time of closure is approximately or equal to 0, ang tawag natin dun is the sudden closure. Kapag yung time to close the bulb is less than the round trip time, ang tawag naman natin dun is the rapid closure. Kapag sudden and rapid closure, okay, paano natin i-compute yung maximum pressure? The maximum pressure is equal to the density of water, velocity of flow, tapos the celerity. So, sudden, pareho lang yun sa instantaneous. Kapag slow closure naman, ito yung T sub C is greater than the round trip time. Ito yung tinatawag natin na the slow closure. Paano natin i-compute yung maximum pressure sa pipe? The maximum pressure is equal to raw velocity multiplied by twice the length divided by the time of closure. So, yun yung dalawang cases natin. So, formula ng pressure maximum. So, ang sabi naman niya sa number 56 is instantaneous. Pareho lang ito siguro sa sudden, mabilisan. Okay, sudden or rapid, mabilis. So, kung ganon, ito yung gagamitin natin. Okay, so we are now computing for the maximum pressure is equal to density of water is 1,000. Ano yung velocity of flow na given? The velocity of flow is 2 meters per second. So that is 2, multiplied by the celerity, 1,222.761. Ang result na unit nito, kung mag-unit analysis kayo, is nasa Pascal. So to be divided by, let's say, 1 megapascal is 1 million pascal, that is 10 raised to 6 pascals. Okay, kunin natin yung maximum pressure for instantaneous or the sudden closure. Okay, so this is 1,000 times 2 times the celerity, 1,222.761. This is in terms of pascals, divided by 1 million, 10 raised to 6. That is 2.446. Sabihin na natin, this is 2.446 mega pascals. So check natin if we have this value sa choices for problem 56. 2.446, that will be letter A. So I think several times na itong lumabas sa board exam, including on our time, nung mismong board exam namin. So dito tayo sa 57 to 59. Water is flowing at a depth of 1.5 meters in a 3 meter wide rectangular channel having n equal to 0.013 and s equal to 0.0009. What is the stage of flow? So parang balik lang tayo sa open channels, kaya lang ito yung critical flow. So para malaman natin yung stage of flow, dapat alam natin yung value ng Froude number. Tapos dito pwede nating tanggalin yung turbulent tsaka laminar dahil sa pipes yung dalawang yan. Pag turbulent or laminar, that is for pipes. So dito sa Froude number, if the Froude number is less than 1, ito yung subcritical. Tapos if the Froude number is equal to 1, ito yung critical flow. Tapos, if the Froude number is greater than 1, ito na yung supercritical. Okay? So, kailangan natin kunin yung Froude number. So, meron tayong dalawang formula for the Froude number, depende sa shape. So, ibibigay ko na lang ulit yung link ng, ng derivation. The Froude number is equal to the velocity divided by the square root of the acceleration due to gravity times the depth. Ito ay applicable kapag rectangular yung channel. Okay, rectangular only. Hindi nyo pwedeng gamitin yan sa triangular channel or trapezoidal channel. Kapag any shape naman, the Froude number is equal to the square root of the discharge squared, the top base divided by the area raised to 3 times the acceleration due to gravity. So, ito naman yung formula natin for any shape. The square root of the discharge squared, top base, divided by the area cubed times the acceleration due to gravity. This is applicable for any section. Okay, so dito, sa example na to, kunin muna natin yung velocity. The velocity of flow. Paano ba kumuha ng velocity of flow last time? The velocity of flow is equal to, by Manning's, 1 over n, hydraulic radius raised to 2 over 3, hydraulic slope raised to 1/2. Ito, ano yung mga given natin dyan? So, ito. So, we are computing now for the velocity of flow. Equal to 1 over, roughness coefficient is 0.013, hydraulic radius is area over wetted perimeter. So, ang area natin is 3 by 1.5 meters. Wetted perimeter is 3 plus twice of 1.5. Kung nakalimutan, recall ninyo ng konti yung lecture natin sa open channels. Raised to over 3, the slope is 0.0009. This is raised to 1/2. Okay, computing for the velocity of flow. Okay, this is 1 over 0.013 multiplied by 3 times the 1.5 divided by 3 plus twice of 1.5, the wetted perimeter. And this is raised to 2 over 3. And the slope is 0.0009. ay raised to 0.5. That is 1.905. Okay, 1.905 meters per second. So, for question number 57, paano ba kumuha ng fraud number? Okay, for 57 number, rectangular naman yan. So, the fraud number is the velocity divided by the square root of acceleration due to gravity times the depth. So, this is 1.905, okay, divided by the square root of 9.81 times ay 1.5. So, yung fraud number natin dito will be equal to, ayun, sige, ilagay na lang natin as answer divided by the square root of the 9.81 times 1.5. That is 0.497, 0.497. This is obviously less than 1. So, ang sagot natin dito, it is a subcritical flow. Check natin for number 57. Ano yung letter na subcritical? That will be letter. So, letter A tayo. So, number 58, determine the critical depth. For critical depth, so again, may mahaba-haba yung derivation ng formula na to. I-send ko na lang ulit yung link kung paano siya na-derive. So, for the critical depth, ay kapag rectangular, ito yung formula natin, we have the unit flow squared divided by the acceleration due to gravity is equal to the critical depth cube. Applicable lang ito kapag rectangular section. Okay, paano naman kapag non-rectangular? Ito yung discharge squared divided by the acceleration due to gravity is equal to area cube divided by the top base. So, ito naman for any section. Okay, ano yung equivalent ng small q? So dito tayo kasi rectangular naman. The small q is equal to the discharge divided by b, or simply equal to, okay, ano ba yung q natin? Area times velocity divided by b. Kapag rectangular lang naman, ito yung bd times the velocity divided by b. So pwede mong i-cancel yung b dito. Okay, magkakaroon ko ng equivalent ng Q as simply the velocity times the depth of flow. So kung kukunin natin yan, the velocity is 1.905 meters per second. The depth of flow is 1.5. So kunin natin yung small q. That is 1.905, okay, multiplied by depth of flow, 1.5 meters. So this is 2.85 ay 75 meters per second. Actually, square meter per second yung unit niya. Okay, so again, applicable lang ito kapag rectangular channel. So that is, okay, mag-substitute na tayo. That is 2.8575. This is squared divided by the acceleration due to gravity, 9.81. So again, ito yung ginagamit ko. Is equal to the critical depth cube. So, kunin natin yung critical depth. This is for question number 57. 57 ba yun? 58 na pala. Problem number 58. So, that is 2.8575. This is squared divided by 9.81. Then, raised to 1 over 3. So, the critical depth is 0.941. 0.941 meters. Meter. Check natin ito sa choices for problem number 58. 0.941. So, pareho yung sagot. Letter A ulit tayo sa number 58. Sa number 59, determine the critical slope. Para makuha yung critical slope, ang gagamitin natin dito is yung critical depth. The critical depth is 0.941. Ganun pa rin yung base width ng channel. 3 meters pa rin yun. So, ang mangyari is, okay, Pag ginamit kasi natin yung critical depth, lahat ng values magiging critical. Pero yung discharge natin, equal lang din yun sa discharge critical. So, ang discharge is area times velocity. Ano yung area ng initial channel natin? Ito yung 3 meters by 1.5 times the velocity is 1.905. Kunin natin yung discharge or pareho lang sa critical discharge. Okay, this is 3 multiplied by 1.5. Yun yung area. Yung velocity of flow, 1.905. Okay, this is 8.573. 8.573 cubic meters per second. So ngayon, gagamitin lang natin ito para makuha yung critical velocity. So that is, discharge critical is area critical, velocity critical. This is 8.573. Ano yung critical area? Critical area kapag ginamit natin yung critical depth. That is 3 meters. Okay, we have 3 meters. Critical depth is 0.941. So instead na 1.5, yun. Palitan lang natin ng 0.941 ng critical depth. Kapag yun yung ginamit natin, ang makukuha na natin dito is the critical velocity. So this value divided by 3, divided by 0.941. So this is our critical velocity, 3.037 meters per second. For problem number 59, kapag ginamit natin yung critical velocity, lahat ng values nagiging critical. 1 over n, hydraulic radius na critical, hydraulic slope na critical. Yeah. So once na ginamit natin yung critical depth, lahat nagiging critical values. So we have that is 3.037 equal to 1 over roughness coefficient 0.013. Ano yung ating critical hydraulic radius? Area, yun yung 3 times 0.941 divided by wetted perimeter, 3 plus twice of 0.941. And this is raised to 2 over 3 multiplied by the critical slope raised to 1/2. Kunin natin yung critical slope. So that is the critical velocity equal to 1 over 0.013. Hydraulic radius is area 3 times the critical depth, 0.941. Divided by wetted perimeter, 3 plus 2 times 0.941. Okay, this is raised to 2 over 3. And then, alpha x na lang ito for the unknown. Alpha x ay raised to 1/2 or 0.5. So, shift solve. 3.23 times 10 raised to negative 3. 3.23 times 10 raised to negative 3. Check natin if we have this value sa choices sa question number 59. 3.23. Okay, pinakamalapit na dito is 3.24. 0.00324. Yun na yung pinakamalapit na value since negative 3. Dalawang 0 yon before 3. So letter B tayo. So this will be our solution for problem 57 to 59. Okay, so for the last problem, number 60, a triangular channel carries a discharge of 15 cubic meters per second having a side slope of 1:1. Compute its critical velocity. So ito yung case ng critical depth na hindi naman siya rectangular. So paano mag-compute ng critical depth kapag any section other than rectangle? Ito yung discharge squared divided by the acceleration due to gravity is equal to the area of the section cubed divided by the top base. So ang gagawin lang natin dito, express lang lahat natin ng unknowns, gawin natin in terms of the critical depth. So ito yung top base niya. Okay, the top base. So tapos since 1:1, Di ba pag 1:1, okay, horizontal is equal to vertical. So, kung in terms of critical depth yung ginawa natin sa depth, di critical depth din ito, critical depth din yan. Since 1:1, slope. So, ang magiging equivalent ng top base is twice the critical depth. Tapos, ano yung area ng triangular section na yan? The area is 1/2 of the top base times the critical depth, or 1/2 base times height halos. This is 1/2 of top base natin is twice the critical depth, and the depth is the critical depth. Ginawa lang natin in terms of critical depth lahat. So we have the area is equal to, that is the critical depth squared. Yun. Substitute natin dito sa formula for the critical depth for any section. So we have the discharge is equal to 15. So this is 15 squared, 15 cubic meters per second, divided by 9.81 is equal to area. Ang equivalent ng area is the critical depth squared cube. Divided by, anong equivalent ng top base kanina? And the top base is 2dc. Yun. So sinubstitute ko lang yung equivalent ng area at saka nung top base. So, the top base is twice the critical depth. Yan. So, we are now computing for the critical depth. So, this is 15 squared divided by 9.81. Times 2. Yun, mag-simplify nga muna tayo dito. So, cancel yung critical depth. 3 times 2 is 6 minus 1. So, magiging 5. So, yung value na to ay raised to 1/5. Is 2.149. 2.149 meters. That will be the critical depth. And double check natin. Okay, so ito na yung ating critical depth, 2.149 meters. Okay, kapag ginamit natin kasi yung critical depth, lahat ng values magiging critical. Okay? Pero take note na yung law natin sa continuity, the discharge is simply equal to the discharge, the critical discharge, and simply equal to the area critical multiplied by the velocity critical. So again, kapag ginamit ko na yung critical depth, ang ibibigay na nito ay mga critical values. So critical area, critical velocity. So ano pala yung equivalent ng critical area natin kanina? Ito yon. So if we are using the critical depth, that is the critical depth squared, critical area na rin ito. So, kinuha ko lang dito sa initial equation, isa sa initial equation natin kanina. So, if we are using the critical depth, that is already a critical area. So, mag-substitute na lang tayo. Ano yung discharge kanina? That is equal to 15 cubic meters per second is equal to area critical. Ang area critical is the critical depth squared. Ang nakuha natin na critical depth is 2.149 squared multiplied by the critical velocity. So, critical velocity na to dahil ginamit natin yung critical depth. We have 15. This is divided by 2.149 squared. That is 3.248. 3.248 meters per second. This is the critical velocity. Check natin sa number 60. If you have this answer, 3.248, closest value is 3.25 meters per second. So, ito yung, sabihin natin parang special topic sa open channels, the critical depth.